Sridhar Somnath, the head of Indian Space Research Organization, has said that India intends to design and manufacture reusable rockets for bringing down the cost of putting one satellite into the orbit. Somnath said that it usually takes around $10,000 to $15,000 for putting 1 kilogram of payload into the orbit, which India intends to bring down to $5,000 and even $1,000 per kilogram, which is achievable only when we make use of rockets that can be used more than once. The current operational launch vehicles are expendable because their stages cannot be reused. In 2019, India had planned to reuse the first and the second stage of rocket that goes up into the orbit. But the rockets should be cheap, competitive, and also easy to make. Somnath said that India should come up with reusable rockets in a few years so that all the other active launchers could be decommissioned at the same time, while the reusable rockets would not just bring down the cost of space launches but also heavier payloads could then be launched into space. Now, back in 2016, the Indian Space Agency launched a reusable launch vehicle technology demonstrator, the RLVTD, which was made using a lot of high tech tools and testing equipments. And the 6.5 meters long rocket was made in a period of 5 years using $14 million. However, the final version of this rocket is estimated to be around 40 meters long and would be able to carry Indian astronauts. However, the rocket would be made in 10 to 15 years. That means the reusable launch vehicle would be seen in around 2030s. In order to save the first stage of the rocket, the Indian Space Research Organization had planned to follow the SpaceX methodology of making it land on a pad in the ocean, while in order to use the second stage, the Indian Space Agency had planned to test improved versions of the reusable launch vehicles. As per global trends, India needs to develop heavy launch vehicles, rocket engines, reusable rockets, advanced propulsion systems, advanced materials, dynamic space programs, new generation of aerospace electronics, advanced science missions, and effective integration of the space services.